What's going on, guys? This is going to be a whirlwind tour through Bash. We only have a couple of minutes for this. We're going to whirlwind through it. So very simply, we're going to start with stuff I've already covered in other videos just to kind of review it, and that's input and output redirection and then conditional execution. Very simple. I know they sound scary, but it's just so they sound smarter. We're going to echo something, right? Echo is like the first thing everyone learns. So, hello there. When I write echo hello there is returned on standard out. Any errors are written to standard error. In this case, standard error and standard out both output to the command line right here, the same shell that I'm in. That's lovely. However, it doesn't get us very far. If we ever want to store something, we're going to have to echo it to a file. The way we do that is by redirecting the output. Instead of saying, hey, bring your output to a standard output, we're going to say little arrow, greater than sign, pointing at the file where you want to store that, or the device, or whatever, the place where you want that to go. We'll call it hello.txt. One of these means create the file if it doesn't exist, overwrite it if it does. So hello.txt will create the file. Two of them will create the file if it doesn't exist, but append to the file. It's not going to overwrite anything when you do that. Let's do that. We'll read out hello text, and you can see there's hello there. Now, if I say hello, Boodlehoffer, and I use the single greater than sign, it's going to overwrite what's in there. So the next time I cat it out, it will have a single line. I've got that, and I use the first command again, which is going to append. Pow! Shazam! It appends and does not overwrite. Make sense? One greater than sign is dangerous because you're going to overwrite stuff. This is everyone's favorite mistake to make when writing a log, right? You have some software, it writes to a log, it overwrites the log every single time, and you can't figure out why the log is never longer than a single line. Why? Well, that's because you're not appending. You're not using two of those greater than signs. Wonderful. You can now append to a file and overwrite a file. You're redirecting output. That's what that is. Another thing we're going to learn is we've got a file here called, oh god, you know, this is a bad practice. I want to illustrate this. Test and test file. Like, what was I thinking? They're named almost the same thing. I have no idea what that is. Doesn't matter. We only need test file. I'm gonna just roll test file. Okay, so you can see it's a file with some lines in it, some text with some new lines, and it's lovely. What we want to do is, what are we doing there? Well, we're saying I'd like to use the word count program. I'd like it to count the number of lines in a file. And here I'm redirecting the input. Instead of saying take it from standard input, I'm saying take your input from, so this is the less than sign, test file. And it will look for test file and use whatever's in here as the input for this command. So that's sort of, it's strange because it's kind of like reversed, like the flow of data is actually like here into this program. Makes sense, right? The arrow kind of points where things are going. So another way of writing this is the pipe. So the pipe would, you could say, and this is, you Linux people, don't effing yell at me for doing this. I'm doing it to illustrate a point. I cat out the file, so concatenate and print the file. It's only one file. You should only do this with more than one file, but forget that. So when I cat test file, it gives me the file, but I don't want to see the file on standard output, which is my shell. I instead pipe it. Now the pipe on an American US keyboard layout, it's shift and then the key above the enter button. So cat test file piped, so the output of that, which we just saw, this, piped into another command. We'll use the same one. So this is the same output. Does that make sense? This and this are the same thing. This is a nicer way of writing it. We're going to kind of focus on that in this program because it's about being readable. Here, the flow of data is like, we're going to use this command, and it's going to take stuff from this file. And that's fine, but the data really is moving from here to the left to our program that we're looking at it with. And this is a more faithful representation of, we have some data that we're working on, and we'd like to pipe it through this program, and then that'll be the output. Wonderful. So once you have some output, for example, we can say this still does the same thing. We're just using our sort of order of operations parentheses here to group this and also to visually group it for other people who are looking at our code. And then we'll say done. Yay! What this means is if this succeeds, if this really is just splitting the statement into two pieces, into this piece and into this piece, two statements. The first one executes. It's going to go along and execute this, and it's going to say 11. If it executes without any problems, then it says and do this. If it executes with some kind of problems, then this will not run. So maybe we could show with list some non-existent file and echo success. So you can see it's throwing an error. This is standard error, also the shell. And this never runs because the first thing didn't complete successfully. So here, this completes successfully, so it echoes done, as you can see here. And if it does not complete successfully, the second part doesn't even run. It never even looks at it. Wonderful. There you go. Conditional execution. The converse is or. So if this doesn't complete, we'll say, well, whatever. We'll say echo success because we don't want it to complete. It will echo success. So what the or means is if either of these things turns out to be true, if either of them is true, so if either this side, or if this side isn't true, if the other one is, then this will return true. Which means, even once this has failed, there's still a chance that the other one will complete successfully, so it says, well, I only need one of them, so I gotta try both if the first one fails. If the first one's successful, the second one won't. This is the inverse of that. Okay, so we're talking about like basically a mathematical operation. It's very simple, but it still is math, so exercise that part of your brain. And means both of these things have to be true. So if the first one isn't true, we already know both of them can't be true. So we're not even going to try the second one. Okay, does that sort of make sense? I'm repeating myself here. If you're sitting here going, oh my god, why is he repeating that 7 times? It's because you already understand it. It takes a while to sink in the first time you have to learn this. So I'm doing this for the people that are still shaking their heads at this. And or. Okay, so you've looked at input and output redirection, but just so we've covered it, you can redirect only, for example, standard error, like this. So you could say some command, and only the errors to, error log or whatever. Otherwise, if you want standard error and standard out, you could say this. And this is where the file descriptors, right? Standard in is 0. I mean, you would never use it, would be the other way. But 1 is only standard out. 2 is only standard error. Wunderbar. So this is really just a review of what I've covered in other videos, just so you're up to speed if you haven't seen those. In the next video, we're going to be talking about variables and quoting, which is where it starts to get interesting. See you there.